Okay, so let's try a few more of these analyzing arguments. So the idea, step 1, apply P's and Q's and R's to all of your component statements. Write them as if-then statements or and statements, or which are conjunctions, or disjunctions, which are or statements. Whatever applies. There is a lot of if-then going on in here. Take each premise, which is each input that goes into your argument. There's a premise 1 for this one and a premise 2 here. Write those premises as a conjunction. In other words, an and then finally write an if-then statement for your and that implies the conclusion. So let's do that. Let's see if we can do this all on one page. If you can get rid of the skeleton in your closet, you'd best teach it to dance. So another quote from George Bernard Shaw this time. It's a cute one. If you can't get rid of the skeleton in your closet, you'd best teach it to dance. You can get rid of the skeleton in your closet. You'd best not teach it to dance. So there's lots of negation going on here. And so you've got to decide what you want your P's and Q's to be. If you can get rid of the skeleton in your closet, let's call that P if you want to. So this is going to be P, which means if you can't get rid of the skeleton in your closet, it is not P. Are you good with that? So if you can't get rid of the skeleton in your closet, let's call that not P. You'd best teach it to dance. We can call that, I'm going to underline that, Q. And it is an if-then statement. You can see it. If you can't get rid of the skeleton in your closet, so if not P, then Q. You best teach it to dance. And then the last statement, you'd best not teach it to dance, so that would be not Q. You agree? So, here we go. So, I'm going to get rid of this P down here because it's I'm not understanding what it's saying. If you can't get rid of the skeleton in your closet, so not P, if not P, then Q. That's premise number 1. You can get rid of the skeleton in your closet. That is P, right? And then you'd best not teach it to dance. That is not Q as the conclusion. Right? Okay, so what are we going to do? We're going to do in parentheses, not P implies Q, and the second premise, P. Put that in brackets as an if-then statement. That implies not Q. So we can do this. How many rows do we have? Well, we just have 2 components, right? So it's going to be 2 to the second power, or 4 rows. Definitely 4 rows with a 5th header. So I've got that this time for you. Now, do I have the right amount of columns? So we need a P. We need a Q. I'm not digging the green on the orange. I'm sorry, y'all. Hold on just a minute. Let's change this to black. Can't handle it. Okay, so here we go. So we got P and then Q, and then we also have a not P and a not Q. And then our first statement right here, our premise, not P implies Q, and then our and statement. So not P implies Q and P, and then finally, look, I have the right number of columns this time, and then we have not P implies Q and P. That's an if-then statement, implies not Q. In other words, everything. So let's fill it in. So our first column is true, true, false, false. You know the drill, right? And then true, false, true, false. Now we're going to start negating our statement. So not P is going to be false, false, true, true, and then not Q. So I changed the Q column to false, true, false, true. And now the fun begins. So we're going to do not P. I'm going to put a star above it, and then it implies Q. So I'm going backwards. Let's use an arrow. So not P implies Q. So false implies true. Remember, that's true. If you start with a false statement, that's true. False implies false. That's also true. True implies true is true. True implies false is the only false that we're going to have, because that's the only time an if-then is false. So again, I did not P implies Q. Now I'm doing an and statement. So I'm doing the column we just did, and then and with P. And remember, ands are true when both statements are true. So true and true is true. True and true is true again. True and false together is false. And false is false. And then for our last column, and this is how we find out if our argument is valid or not, is we have an if-then statement. So we're doing not P implies Q and P. So we're going to do this implies not Q. So we've got this column right here, and then it implies not Q. So true implies false. That, remember, is false. We already know this is not a valid argument, don't we? True implies true is true. False implies false is true. False implies true is true. But right here, we know right off the bat this is not a valid argument. Okay, I've got two more of these arguments for you. We'll try to make it quick, and then we'll talk about the names of them, and then call this chapter completed. So if Max plays, the opponent gets shut out. You agree that's an if-then statement, right? So if Max plays, let's call that P. The opponent gets shut out, let's call that Q, right? So we have if P, then Q. That's our premise number one. The opponent does not get shut out. Now notice that's the negation of our Q. The opponent gets shut out. The opponent does not get shut out, so that is a not Q. So we're going to say and not Q. Now that is premise 1 and premise 2. Then remember what you do. You put some brackets around that, make an if-then statement. Max does not play. Well, that's the negation of your P, right? That is not P. Are you okay with this? It was fast this time. If that seemed too fast, then you probably didn't watch part 1 of the video. So go back and watch part 1 where I do this much slower. Now we've got it down to a nice art and we can fly through this. So how do I set this up? First of all, how many components do we have? Just 2. So our number of rows is always 2 to how many components you have. 2 to the 4 squared is 4 plus a row, right? So we have 5 rows, I'm sorry. So 1, 2, 3, 4, 5. 4 plus a header. So it's always the 4. Whenever they ask, it's 4 rows. But we need a header to label all this stuff. How many columns do we need? Well, let's just fill it in. We need a column for P and a column for Q. But notice we've negated both P and Q. There's a not Q right here, a not P right here. So I need not P and not Q. Now where you put those in the mix is it's entirely up to you, but I like to start with P and Q. It makes it so much easier when I do my initial filling stuff in. Okay? And then we have P implies Q. That was premise 1. And then premise 2 was, I didn't make these columns wide enough. P implies Q and not Q. And then finally I'm just going to put whole statement right here because it's just not going to fit. So let's fill in. So P is going to be true, true, false, false, because we've done this so many times, we know that for a fact. And then true, false, true, false. How did I do that? I took my 4 rows and I split it in half, 2 and 2. And then I took the 2 and split it in half, 1 and 1, all the way down. Not P, I changed my P column. So false, false, true, true. Not Q, I changed my Q column. So it's going to be false, true, false, true. And now we do P implies Q. So I'm way back over here. P implies Q. Remember, that is going to be true unless I have a true false, which is the second row. So my true false is false, but true true on the top row is true. False true is true because any time you start an if then with a false, it is true. Now, P implies Q and not Q. Okay, so I'm doing an and. P implies Q right here, and then not Q, which happens to be right next to it. That's convenient right there. Ands are only true when both statements are true. So the first one, false true, is false. True false is also false. False true is false. True true. The last row is the only true statement in the mix. And now, conclusion, which is P implies Q and not Q implies not P. In other words, the whole statement here. So we've got the column P implies Q and not Q. We've got that one. Now notice right here that implies, pen's not working, that implies not P. Okay, so right here implies not P. There we go. So I start with this one and then I end with this one. If then. So false implies false. Now we know that's true because anytime an if then starts with false, it's true, which means this one's starting with a false, so that has to be true, and it's false implies false. Then this is false implies true, which is a true statement because again we're starting with a false. And then finally the last one doesn't start with a false, but it's true implies true, which is also true. Now what do we find out? Hey, we have a tautology. This is a true statement. Now you might have noticed, or maybe you didn't, but this is what we call the contrapositive. So we have P implies Q combined with not Q. Remember, the contrapositive is when you flip this around. Remember, Missy Elliott, flip it around and you negate it. So not Q implies not P. And look, that's what we have. Not Q implies not P. So if we had thought about that when we set all this up, we would have known that it was a valid argument. Let's do one more argument and then talk about the names of these issues. All right, our last problem. We have Mia kicks, or Maya, whatever you prefer, kicks, or Drew passes. Drew does not pass. Maya kicks. Okay, pretty basic here, so let's just see if we can write this down. And notice this is the first time we've had an or statement in our premise. Okay, so this is premise number 1 right here, and we can say Maya kicks, let's call that P, and Drew passes, let's call that Q. So that would be P or Q. Drew does not pass, so that'd be not Q. You comfortable with that? So that's not Q. And then what's our conclusion? Maya kicks, so that is P. So rehash, Maya kicks or Drew passes. Pretty straightforward. That's P or Q. So Maya kicks is P, Drew passes is Q. And then it says Drew does not pass. So that's just negating our Q, so not Q. And then Maya kicks, which is exactly what P is. So does that imply P? So here we go. So we need a P column, we need a Q column, and we also have a not Q in our problem. And again, the contrast of red is a little much, so hang with me while I just change this to black so it's not so hard on the eyes. So we have a P column, a Q column, and a not Q column. We also need a P or Q column, and remember what we do is we take this one with an and. So this is P or Q and not Q. So that's going to be this column. So P or Q and not Q. Now it would be perfectly okay to just write and right there if you want. And then this last one is the whole statement, which is really our if then, right? So we do if that, then does that imply P? And that's the big question. Do we get a tautology when we do this? So we start with our P column. We know we do true, true, false, false. And then our Q column, we alternate true, false, true, false. Now I'm negating Q, so that's going to be false, true, false, true. Now P or Q, so true or true is true. We haven't done an or in a while. Remember, ors are true if either of the statements are true. So true or false is true. False or true is also true. And false, false is the only time an or statement is false. Now we're doing an and statement with the P or Q combined with the not Q. Ands are only true when they're both true. And look, they're not both true anywhere. False, true is false. Oh, yes, they are. True, true is true, second row. False, true is false. And true, false is false. Finally, the whole statement, which is an if-then statement. And we're doing if, and then our not Q statement. So false implies false. We know that's true, right? Because an if-then statement that starts with false is true. True implies true is also true. false implies false is true, and false implies true is true. Again, if you start with a false, like row 1, 3, and 4, it's going to be true. And then if you start with a true, then your then must be true, and that was the case there. So once again, we have a tautology. What does that mean? That this is a valid argument. All right, now let's talk about some of these names. And to me, the names of these really, truly is less important than being able to prove if it's true or false. But what's the point of having names? Well, if you can recognize a certain argument, then you don't even have to do a truth table for it. You know that it's true about this particular argument. And let me show you what I mean. So right here, there's this one called Modus Ponens. And so you'll notice that if you have this first column here, if you have P implies Q, and your second premise is P, then you know it's Q. That's just really your if-then statement. And we did a problem like that. I could go back and find it. Let's see if we can find the Modus Ponens. Hold on just a minute. Check this out. It was the Auburn problem. Okay, and so this came from the part 1 of the video. We have P implies Q, and then we have P for our second premise, and that implies Q, and we found that it was a valid argument, and this is the Modus Ponens argument. Had we known that before we did this problem, we would have just said it's true by Modus Ponens. Next we have Modus Tollens. So you notice it's an if P then Q, and then if we have not Q, that implies not P. Remember the contrapositive problem we did just a minute ago? Let me go find that one. That is Modus Tollens. And this was the problem about Max plays and the opponent gets shut out. If the opponent does not get shut out, that means Max does not play. And it was a true statement. And again, to remind you, this was the Modus Tollens argument. Now, when we set this up, if we would have noticed that we had, P implies Q, get that pen working. So P implies Q, and then we had not Q, and our conclusion was not P. Right there, we would have known that it's valid, again, by Modus Tollens. Pretty neat, huh? That's why you want to name these things, because they've already been proven in the past. Heck, we proved it. Okay, now, the Disjunctive Syllogism. Love these names, don't you? P or Q. And then this second premise is not P. And that implies Q. Did we do one of those? Let's check. Look, we did. That's our last problem. P or Q and not Q implies P. That's exactly what we have. P or Q and not Q implies P. So let's go back and look. P or Q and not P. We had not Q implies P. We had it slightly different, but I believe that is the same argument. Since we have an or statement, that would have to be the same argument. And then reasoning by transitivity, that was actually our very first problem. So back to the part 1 video. Remember, if you use binoculars, then you get a glimpse of the bald eagle. Well, if you get a glimpse of the bald eagle, then you're amazed. So can we say if you use binoculars, then you'd be amazed? Absolutely. That is the transitivity problem. So here we go. P implies Q, Q implies R, P implies R, reasoning the transitivity. But on top of that, we have some fallacies. And then you have an invalid argument if you have P implies Q, and then you're given Q implies P. That is not true, right? That's the converse. When you change the order, remember when you reverse it, then you don't have a true statement anymore. So that definitely is a fallacy of converse. And then a fallacy of inverse, if you have P implies Q, does not P imply not Q? No, it doesn't. And then remember, again, Missy Elliott, then that's our reverse it. Our flip it. Inverse is flip it. And that gives you a fallacy as well. It's just not a valid argument. All right, so that's validating arguments. This can get really, really deep. I'm not going to make it really, really deep. If you can do what we did in the video, you'll be just fine as far as this material goes. Hope you have a lovely day.